All right, hi everybody. It's a continuation from yesterday's lesson. So we're looking at 14.4b. And the first example on your note sheet should say the volume V of a right circular cone of height h equals 6 feet. So find that problem where that's the kind of the first line of it. Okay, so yesterday, I'm going to spell it right today. I noticed I spelled it wrong yesterday. So today, we are looking for the instantaneous rate of change. Now remember yesterday that phrase instantaneous rate of change really means we're just taking that derivative. Okay, so instantaneous rate of change. In number 1, this problem with words in it, in the second line, towards the end, it says, find the instantaneous rate of change. Underline that line, circle it, highlight it, so that you remember that's the phrase that means find the derivative. Okay, we are also going to give you a formula in each problem, so you don't have to come up with the formula on your own, you just have to know how to use it. So here, we're going to find the volume of a cone, and if you look, it says volume is equal to 1/3 pi r squared h. We're going to simplify that a little bit, and we're going to use the 2 pi r squared. Okay, so we're using this formula that I gave you, but if you notice it's v of r, because r is the variable here, so that's always going to match. Okay, so now we want the rate of change as this volume is changing, and we want the exact moment when r is 3. Okay, so now it's the exact same problem that we did yesterday, that alternative form of the definition of derivative. So I want the limit as, instead of x, we're now going to have r, as r approaches 3. Just like yesterday we had an x there, now we have r there. We still need two points. So my 1 is just the r. If I plug r in here, it's that same function. But if I plug 3 in there, and I plug 3 into here, I get 9 times 2, and I get 18 pi. All right, so now I'm going to do my slope formula with those 2 points. So 2 pi r squared minus 18 pi all over r minus 3. Again, from yesterday, if you plug 3 into here, that's a problem. We get 0 down there, so we got to play around with this for a little bit. Again, don't forget, always rewrite that limit piece. Factor out at 2 pi. And then I can go again. A shameless plug for TikTok from my youngest child, Ken's Resh. Go ahead, follow it. She would appreciate all the likes possible. That is her COVID-19 goal here, is to get some likes on TikTok. All right, so back here, that cancels. Leaving with just 2 pi times r plus 3. So if I plug 3 in here, I get 6. 6 times 2, our derivative is 12 pi. You can just leave it with that, or you can change it to decimal, an equivalent decimal, but 12 pi is just fine with us. All right, there's number 1. Let's take a look at number 2, and then that's it for the notes for today. All right, number 2. Number 2 says we have the surface area of a sphere is now changing. So I'm going to worry about this formula, S of r, is equal to 4 pi r squared. And I want to know when r is equal to 2. All right, same exact problem as the one before it. We're going to go through and we're going to put in r, getting me that same formula. Plug in 2, and I get 16 pi. And so when I write it out, I have the limit as r approaches 2. Again, this 2 is going to match the radius. And then I'm going to find the slope between those two. So 4 pi r squared minus 16 pi all over r minus 2. And then we're just going to go through and same thing as before, factor, because when I plug 2 in here, I get 0. So I'm going to have to play around with that. So when I took out the 4 pi, that leaves me with that difference of 2 squares. So I can factor that again. So now that cancels. When I plug 2 into here, I get 4. 4 times 4 pi is 16 pi. And then again, that is your answer, and that's all we are looking for in this part. All right, so that officially ends chapter 14/chapter 1 in the calculus book. You'll be getting some reviews with the answers tomorrow, so take a look at those over the weekend. And then we will regroup for chapter 2 next week. All right, again, Mrs. Cook and I will be around to answer questions. All right, have a good one. Bye-bye.